All right, let's see some more crunchy rules here. Specifically this one, if we have a to the power of m over n, there are two ways that we can write these, and these all have an equal sign because they're all equivalent. So a to the power of 1 over n, quantity to the power of m, is the exact same thing as a to the power of m, all raised to the power of 1 over n. And to illustrate this, let me just give you these two examples here to illustrate both of these so that this is clear. And then we'll do some examples here. So using this rule right here, we can write it first of all like this. You see, we're going to take the denominator of our power, and we're going to leave that inside. So we can rewrite this as 27 to the power of 1 over 3 quantity squared. Okay, so I just applied the middle rule right there. Now, but there's another way that you can write this. It's not that we have to do that every single time, like do the second way, but just showing that there are two ways of writing the same thing. Or we can write this as 27 squared and raise that all to the power of 1 over 3. Okay, and they both give us the same answer. You say, what? Well, what do you mean about that? We get the same answer? Well, let me show you here. What's 27 to the power of 1 over 3? Well, again, we've learned now that 27 to the power of 1 over 3 means the cube root of 27. And the cube root of 27 is 3, and then we square 3, and then we're going to get 9. Okay? Now let's go down right here and see what we get for this guy. Now we can square 27, and just do that real quick on my calculator here. Don't got that guy memorized. So that's going to give us 729. Okay, so if we square 27, we get 729. Now, if you raise that to the power of 1/3, or again, that means we take the cube root of that. Okay, and if you take the cube root of that, that's going to give you 9 as well. Ha-ha! Aha! Ah, you a trickery. And see how we get the same number, right? And that's just showing you that you can rewrite it both ways. Okay? All right. And this is the same rendition of what we just kind of talked about right now, is that so a to the power of m over n is equal to the nth root of a to the m. And again, we just wrote that right there, right? We just wrote that as a to the power of 1 over m all raised to the n. I mean, isn't that the same thing? This, I'm sorry, wait, that's not true. Sorry, hold on. Scratch that. JK. Let's start that over again. So the a to the power of m can be written inside, so a to the power of m, but then what's this whole thing has an nth root. So if it's the nth root, then we raise that to 1 over n. Okay, so and that's what we were writing up just above right now. So you can write it as that has a root, or you can write it as a fractional exponent. And this is the same thing as well, right? We can switch m and n. I can say a to the power of 1 over n, all raised to the power of m. See, so this right here is giving this equivalent, and this guy is giving that equivalent. And let me just show you again just one example of each of these guys right here. If I wanted to illustrate this guy right here. Okay, so we have a to the power of m right here. So we're going to have 8 squared, and then this 3 right here is going to be the cube root of 8 squared. And we know what 8 squared is. 8 squared is 64, right? And then we take 64 and we raise that to the power of 1/3, or we take the third root, right? And this is going to give us 4. Okay, so 64, and then the third root of that is going to give us 4. Or we can do it this way. This is really cool. Or we can write it as the third root of 8 and then square it. Okay, and so I'm just showing you that you can interchange these. You can either do the square first and then take the cube root, or in this case now we're going to take the third root first, or the cube root, and then we're going to square it. And we're going to get the same thing. 8 to the power of, or I'm sorry, the third root of 8 is going to give us 2. And then we raise that to the power of 2, and we get 4. Okay, so using all those cool rules, let's go ahead and blaze through a couple of examples now. Okay, example 4. So we're just going to write each of these guys as a radical. That's all we're doing. We're not really trying to find a numerical value. And a lot of these you can't find a nice numerical value. We're just going to write them as a radical. And we're going to assume that the other variables are positive. So we're not going to say, oh, this one's not possible because it has a negative radical. Okay, so this right here can be simply written as the square root of 19. And that's because the denominator of our exponent is 2. Now this guy can be written again as 2 different ways, and they're both correct. So I'm going to show you both of them right here, and then from now on I'll just do one of them. So we can write that as 11 cubed, and then take the 4th root of that. Okay, so I can write it like that, or I can express my answer as the following. I can say the 4th root of 11, and then raise that all to the power of 3. So basically any answer is the same. You want to put the cube inside, or if you want to put the cube on the outside, we're going to get the same thing right there. Okay, doing this guy right here. Now this guy's pretty interesting now, because it's the only thing that's being raised to a power is the x. Very interesting. So that means we leave the 14 there. So it's 14 times. Now it's this whole thing. And now let's rewrite this as a radical. So I'm going to write that as the cube root of x. And then I'm going to raise that whole thing to the power of 2. Okay, so just notice that the only thing that's being raised to a power is the x, not the 14x. Okay, going on now to part D here. If I want to rewrite this, I can write that as 5, and then let's see, the 5th roots of x, and raise that whole thing to the power of 3. And then this guy right here, now check this out. Check it. This has parentheses, which means 2x is being raised to the power of 3 over 5. So unlike this guy where it's just the x that's being raised, the whole thing 2x is being raised. So the way I'm going to write this guy now is I'm going to say the 5th roots of 2x. You see, I'm not putting the 2 on the outside. I'm putting the 5th root of 2x. You say, well, why is that now? Because what's being raised to a power is 2x. We call this like our base right here. So if the whatever the base is, that has to go inside of our radical. All right. And then, of course, we have to raise this all to the power of 5. All right. Let's come over here now. Now, what happens when we have this negative exponent? Well, remember we talked about last example or two where anytime we have a negative exponent, we have to do the reciprocal, right? So we do 1 over x to the power of 5 over 7. And then we just rewrite now the denominator. So that could be 1 over the 7th roots of x, and raise that all to the power of 5. Oh, hey, today Cinco de Mayo too, May 5th. Yeah. Okay, so keep going on here. So now notice now x squared plus y squared, the whole thing is being raised to the 1/3. So that means the answer would be the 3rd root of the whole thing, x squared plus y squared. Okay, and let's top it all off with let's go the other way around. Now let's write each of these as a radical. I'm sorry, let's write each radical as an exponent. So right now this is in radical form. If I want to write this as an exponent, well, it's not the same thing as 37 to the 1/2, right? Because there's like a little ghostly 2. Okay, coming right over here. Let's see, we can rewrite this as g. Now watch this now. Since this is the 4th root, whatever the root is, that's always on the bottom of our exponent, right? So it's going to be 8 over 4. You see, this 4 now goes in the denominator of our exponent. And we can simplify 8 over 4. So that's just going to be g squared. Pretty sweet. That became that. Radicaliciously cool. And last but not least, the 8th root of z to the power of 8. Again, the root will become the denominator of our power. So it's z to the power of 8 over 8, which is just simply z. And that's it.